Hello, differential equation students, and welcome back to section 8.3. We're doing non-homogeneous systems of differential equations. And this will be the second and final example. Here, when I get towards the end, we're going to introduce a initial condition, okay? Which, I'm just going to leave out in the water for now, okay? But here at the end, we'll introduce it at the end so we can actually work through one of those as well and see kind of how that works out. So first thing I'd like to do is I'd like to solve this. Of course, what we did first, right, is we found the homogeneous solution in the last one. That's what I want to do here too. This is A, right? This T, and then this constants, right? These are constants that are sitting over here. We're just going to assume like they're not even there, right? We're just going to assume that those are 0 for the homogeneous version, which then means that I have the determinant, right, of my characteristic equations, which would be 6 minus lambda. I would have a 1, a 4, 3 minus lambda, and that would be what, 18 minus 9 lambda plus lambda squared minus, it's a 4, which then gives me, that'd be a lambda squared minus 9 lambda, and then that's what, plus 14. Do I know factors of 14 that add to 9? Yeah, I think I do. It's 7 and 2. Solving them, I would have lambda 1 is equal to, let's have it be 7 like the last one. Lambda 2 would be equal to the 2 then. Okay. And what we do after that, of course, you should kind of have this rhythm down. We do if lambda 1 equals 7, then I get, well, put the 7 in here. That'd be a negative 1, 1, 4. That'd be a negative 4. And then I say times k, big K sub 1 would equal 0. Working this out, I would have a negative k sub 1 and plus k sub 1 equals 0, which of course is k sub, or I'm sorry, this is a 2. K sub 1 equals k sub 2. It doesn't really matter what you choose here because big K sub 1 is going to be a 1, 1 either way, right? You could scale it up if you really wanted. You could make it 2, 2. There's no need to do that. Absolutely no need to make it bigger than it needs to be. So then the next thing is if lambda sub 2 is equal to the 2, then I would have, well, that'd be a 4. This would be a, oh, I almost put a 2 there. This would be a 1 still, this is a 4 still, and this is a 1. Times big K sub 2 equals 0. Of course, this yields 4 K sub 1 plus K sub 2 equals 0, which would be, K sub 2 is equal to a negative 4 K sub 1, which creates big K sub 2 equal to, if I let K sub 1 equal this 1, then I would have a negative 4 for my K sub 2. Okay. And now I have those two, right? That didn't seem too bad. I should actually already have then the homogeneous solution, which would be C sub 1. And I would have 1, 1 here for my big K sub 1, which was with the 7. And then for my 2, I had 1 and this negative 4, which was with the 2. And the next thing I need to do is I need to figure out a way to set up myself to be successful with this particular solution. And the way I like to do these ones, get this out of my way here. The way I like to do these ones here is I really just think about it like, okay, there's got to be something here and something there times AT plus something and something, right? And what I'm creating here is actually what I imagine my particular solution to be. It is. That's exactly what I imagine my particular solution to be. Okay, so there we go. So that's what I think it is. It's just this big thing sitting down here, right? This thing here. Well, okay, so if I write it down here where I can see it a little bit better, I would have x sub p is equal to, I had a1, b1 with the t plus a2, b2, which then means that big X prime sub p, my particular derivative, right? That means this thing here are constants. They're gone. That's 0. Then I would just be left with, well, this t drops out, so it's just a sub 1, b sub 1. Now, setting it up, right, I would have, well, the derivative, which is a sub 1, b sub 1, is equal to, it was my a, which is 6, 1, 4, 3. And then I had x. Ooh, okay, x, don't forget, was this entire thing. So maybe it would be wise for me to change colors here. This whole section right here was actually the x. So when I plug it in here, it's going to be a sub 1, b sub 1, t plus a sub 2, b sub 2. Close that. Then I'll continue with my purple color here. It was plus the other, which was 6, negative 10, if I remember from above, times t, plus 0 and 4. Right? And now I have it set up. It would be nice if I could like condense this down a little bit. And the way that I like to condense it down a little bit is, like, I'd like to put all the things with like t's together. Of course, the issues that we're going to run into is I'm multiplying this matrix times this one and times this one over here. Right? I'm multiplying that in there. So maybe I'll take my time here and I'll try to show you some steps. 6 times this a would make 6a sub 1. Then I would also be multiplying the 1 times the b, right? Now this one gets a t, so I might as well just put the t in there with it, right? I can do that, or you can choose to leave it on the outside. It really is completely up to you. I think some of you will probably elect to keep it on the outside, so maybe I'll do the same here. That's the top part, right? Now, that one was times that, so now the bottom one is 4 a sub 1 plus 3 b sub 1, right? These all still have t's. Then I would take this all the way over here, which would then give me a 6 a sub 2 plus b sub 2. And then I'd have a 4a sub 2 plus a 3b sub 2. Then this stuff essentially just gets dropped down. Right? This stuff's just dropping down. And now you can kind of see it starting to take shape. What you'll want to do is you can create either the equations from here, a typical response here. I'm sorry, I forgot to put this plus sign in here. A typical response would probably be to combine any of these things that have t's, such as like these have t's right here and here, and then leave or combine the things that don't have t's. So if I do that, that's 6a sub 1 plus b sub 1. That's with the t plus 6t. So really I have 6a sub 1 plus b sub 1 plus 6. And on the bottom I have 4a sub 1 plus 3b sub 1 minus 10. Those all have t's. Then I have plus, my other equation would be 6, or my other matrix, 6a sub 2 plus b sub 2 plus 0, which I don't have to worry about then. On the second row, I'd have 4a sub 2 plus 3b sub 2 plus 4. And then this is all equal to a sub 1, b sub 1. Okay. And what I think a lot of you would have done is you would have just created these little tiny equations here that I'm about to do now, kind of almost right away. They're not terrible to see that this is the top row, then this one would create the bottom one. And what'll probably be worth it right now is if I try to do a little tidying up, because there's quite a few loose variables running around here. So maybe now would be a good time to pause the video and try to tidy these up and simplify both of these equations the best you can. Now, I've seen that approach when you try to tidy them up and everything, but it really isn't going to help all that much. And here's why. Over here, I essentially have plus 0t and plus 0t, which is actually super helpful because that means this section here has to be that 0. So I have like 6a sub 1 plus b sub 1 plus 6 equals 0. And then I also have this one here would be giving me a 4a sub 1 plus 3b sub 1 minus 10 equals 0. Right? Now, the reason I know that is because this 0t and this stuff with the t's has to be 0. Right? Now, the next thing is then to use the same type of logic, but with these, right? Well, then this thing, this 6a sub 2 plus b sub 2 has to equal, well, the constant that sits over here, okay? And then I would also need these, right? So that's 4a sub 2 plus 3b sub 2 to equal the b sub 1. Right, and hopefully that carries through. Now, how many equations do I have? I have 1, 2, 3, 4, and I have 1, 2, 3, 4 different constants that I'm trying to solve, which should be doable. What you can see is what's really nice is this system is contained, self-contained into a 2x2 because there's a1, b1 sitting over here. So if I could solve this blue system of equations first, it should make life much easier on myself. Which it's not terrible to get these things to match up. Like if I took this one times a negative 3, I would have a negative 18a sub 1 minus 3b sub 1 minus 18 equals 0. Add these, I would have a negative 14a sub 1. These would cancel for me. That'd be a negative 28, dropping it over to the other side would be a positive 28. A sub 1 would then equal a negative 2, right? And if I take that and I inject it like right a sub 1, so if I put it like right here, that would be a 6 times a negative 2 plus b sub 1 plus 6 equals 0. Well, that's a negative 12 plus 6 is a negative 6. That means b sub 1 has to equal 6. Now that I have these, right, I can put a 6 here. I can also put a negative 2 there. And now all of a sudden I have a little tiny baby self-contained system over here. Which again, I mean, this makes life super easy. Well, I multiply this one here by a negative 3. I would have a negative 18. A sub 2 minus 3b sub 2 equals a positive 6. Adding, that gives me a negative 14 a sub 2. These cancel for me. That would be, I'm adding, remember, here now. So this is a 12, which means a sub 2 is equal to, that's 6/7 negative. And I almost made a mistake that would have cost me very dearly. But because I did catch it, I can go back and I can correct it here. And let me show you where I made the mistake. Maybe you saw this. This 4, I seem to have left it out right there. Which of course then when I subtract it will no longer make this a 6, it's a 2. Right? Which then when I combine it with that, that'll make this an 8. then I'll solve my negative 14 a sub 2. But then that makes a sub 2 equal to negative 4 sevenths, right? And plugging it back in, I get b sub 2 equal to 10 sevenths. Feel free to check my math. I feel pretty confident about that one. Now I have a sub 1, b sub 1. Here, maybe I'll even highlight them for you. Now I got a sub 1, b sub 1, b sub 2, and a sub 2, which means I should be ready to put this thing all together. And thinking back to almost the start of the problem, I have my homogeneous one was c sub 1, 1, 1 for my big K sub 1, e, and that was tied with the 7 for my lambda, plus c sub 2, that was 1, negative 4, e to the lambda for that one was 2, plus, well, I got a negative 2 for a sub 1, a 6 for b sub 1, that was with the t, and then I have plus, that's a negative 4 sevenths, and then a 10 sevenths for my a sub 2 and my b sub 2. And now, this thing here would be good enough for the answer, okay? That'd be good enough for the answer if they don't give us any initial values, okay? But, of course, I said I was thinking about adding in some initial values, so I think I will. I think I'll throw in some initial values. In fact, I think I want the initial big X at 0 to be equal to 3 sevenths and negative 4 sevenths. Okay, what does this do to us? Well, it's going to allow us to solve for these constants. Okay, so when I plug in 0 for my t, right, I should get this thing out. So essentially I have a 3 sevenths and a negative 4 sevenths here should equal c sub 1 times, okay, well, clearly there's no t's inside that matrix. But this 7t, when I put in a 0, right, this just goes away. So I don't even have to worry about that here. Plus c sub 2, 1, negative 4. Well, again, here, that's just going to go away, so I don't even have to worry about that. Now, this 0 here makes this whole matrix fall off. Don't need to worry about that. Plus, that was negative 4 sevenths and 10 sevenths, which really these create a couple different equations. This is 3 sevenths equals c sub 1 plus c sub 2 minus 4 sevenths. And this other one would be a negative 4 sevenths equals c sub 1 minus 4 c sub 2 plus 10 sevenths. Simplifying these down, well, if I subtract the 4 sevenths over, that would be 7 sevenths, so that's just a 1 equals c sub 1 plus c sub 2. Here, doing the same thing, subtracting that over, I'd be negative 14 sevenths, which is negative 2, equals c sub 1 minus 4c sub 2. Oh, I see these already. I can subtract them, right, which will make this a plus, a negative plus, which is 3 here. These cancel. That's a 5c sub 2, which gives me a c sub 2 of 3/5. To solve, I would plug back into, you know, you can choose which one you want, but I'm probably going to take this, and I'm probably going to plug it in right here, which is then maybe 1, which I know to be 5/5 minus 3/5 equals c sub 1, which means that this is 2/5, right, equals c sub 1. And now I'm ready. I am ready to write this whole thing out. Of course, I'm probably going to take the lazy road, because I already have this stuff listed out, but you would need to be writing this whole black thing down again. And what would you replace? Well, we just figured out that c sub 1 is 2/5 and c sub 2 is 3/5, so I would take this out. I would put the 2/5 here, and then I would put the 3/5 here. And there we'd have our complete solution. Okay. And that actually wraps up Unit 4. Okay, that wraps up Unit 4. I was thinking about doing 8.4, but I don't think that I'll have enough time. So feel free to study that on your own. Also, you should feel free to study 2.6, which is an introduction to numerical methods, where Newton's method is applied.